This is Learning Assessment Problem 816. The problem-solving strategy that will apply here is that of AC steady-state analysis of complex impedance circuits. Here we have a voltage source V sub S with an unknown quantity, and we are given some information about a voltage across this resistor VO is equal to the phasor 8 at an angle of 45 degrees volts. And we are asked to determine the V sub S quantity with that information. We have currents labeled I1, I2, and I3. We're going to label a voltage across this capacitor V sub C for use. We are going to label a voltage across this capacitor V sub C. Okay, to proceed with the analysis, with the information given, we may calculate the phasor current I3 as that phasor output voltage VO divided across To proceed with the analysis, we can first calculate that phasor current I3, which is the phasor output voltage VO divided by 2 ohms, and this is equal to 8 at an angle of 45 degrees volts divided by 2 ohms, and the current is equal to 4 at an angle of 45 degrees amps. This I3 is represented in the rectangular format as 2.28 I3 is represented in the rectangular format as 2.828 plus J 2.828 amperes. The capacitor voltage now can be obtained as its impedance minus J2 times the current I3. This is equal to 2 at an angle of minus 90 degrees for the impedance times the current, which is 4 at an angle of 45 degrees amperes, and this is equal to 8 at an angle of minus 45 degrees volts. The voltage V1 in the circuit, V1 will be, by Kirchhoff's voltage law, the sum of VC plus VO. This will be 8 at an angle of minus 45 degrees for VC plus 8 at an angle of 45 degrees for the voltage V1 in the circuit can be obtained by Kirchhoff's voltage law as the sum of VC plus VO, and this will equal 8 at an angle of minus 45 degrees for the capacitor voltage plus 8 at an angle of plus 45 degrees for that resistor voltage. Because these have equal amplitudes and they are 90 degrees. Because these have equal amplitudes of 8 volts and they are displaced by plus and minus 45 degrees, the imaginary parts will cancel, and we just have this is equal to 2 times 8 cosine 45 degrees at an angle of 0 degrees, or the V1 is equal to 11.314 at an angle of 0 degrees volts. Now we can calculate the current I2 flowing downward through the inductor. So I2, phasor form, will be this voltage which we've just discovered, V1, divided by the impedance of the inductor, J2 ohms. This will be 11.314, an angle of 0 degrees, volts divided by 2 at an angle of 90 degrees, ohms. And this equals 5.657 at an angle of minus 90 degrees, amperes. So that's the current I2. Then the current I1 is equal to I2 plus I3, and this is equal to 0 minus J 5.657 amperes. That's the I2 component. And then we'll add to that 2.828 plus J 2.828 amperes. That's the I3 component. And we obtain that I1 is equal to 2.828 minus J 2.828 amperes. These should all be phasor currents and voltages. And then we can say that V2 Now we'll go back to the circuit for a moment and give the name of the voltage across this 2 ohm resistor through which I1 flows. We'll call that V2. So V2 is equal to 2 ohms times the I1 current, and this will be 5.657 minus J 5.657 volts. And finally, the V sub S by KVL is equal to the V2 we just calculated plus the V1 quantity which we previously determined. So that sum will be 5.657 minus J 5.657 volts. And we add to that plus 11.314 plus J0 volts. And this gives us that V sub S is equal to 16.971 minus J 5.657 volts. And we can represent that in the polar format as V sub S is equal to 17.89 at an angle of minus 18.43 degrees volts.